Hi, in this video I'll try to explain the concept of Reynolds number and its equation. I'm taking a typical case of a liquid flow through a pipe, in fact a pipe of circular cross section to make it easy, although Reynolds number can be applied to a variety of other situations. So we have the pipe inside diameter as d and the flow velocity of the fluid as v. What's important conceptually is Reynolds number is a competition, is a contest between momentum forces and the viscous forces, and in fact it is the ratio. Let's look at a slow movement of fluid. I've tried to make an animation with the fluid flowing very slowly. The particles are coming on, and therefore the Reynolds number kind of is low because it depends on the velocity. Low velocity, low Reynolds number, and we can call it a steady flow. There isn't too much of chaos out here. So this is also called as a laminar flow. The spheres in the fluid are coming on pretty smoothly. If we make it faster and we increase the velocity, the amount of chaos in the fluid will increase. You can see all the particles colliding with each other. We are back to a still image. So the high velocity normally leads to a high Reynolds number, and if it's greater than 3000, it's called as turbulent. So there are three stages of classifying a fluid flow. With less than 2000, they call it a steady laminar flow. With greater than 3000 on the right hand side, a turbulent flow. And if the Reynolds number is in between 2000 or 3000, it could be either way. It's an unsteady flow. In terms of equation, since it's the ratio of momentum forces divided by the viscous forces, on the numerator you see all things related to momentum: the density, the velocity, and diameter. You can get a sense of momentum and inertia out of that. In the denominator, it's just pure viscosity, coefficient of viscosity. So this ratio is actually a contest. If the numerator or the momentum forces are greater when we increase the velocity of the flow, obviously the Reynolds number will be very high. If we increase the viscosity, which is the denominator, the whole thing will become cool and Reynolds number will be low. So coming back to the definition, I think it makes sense that it's a ratio of the inertial forces to the viscous forces, and it depends on which is greater. So to go over it once again, in a steady or laminar flow, the denominator is greater, so the viscous forces are greater. We'll get a smooth laminar flow. In a turbulent flow, the numerator is very high. High inertia, high momentum, and we might get eddies, whirlpools, and a lot of disturbed